Hello, it's Mrs. Frasco, and this is the first Chapter 1 Algebra vocabulary lesson. As I talked about in class, feel free to stop it along the way, hit pause, go back, read, listen, catch up, anything you want. I will go fairly fast. I'll go through each word. I'll kind of tell you when I'm coming to the end so that you can hit pause if you want to, and then I'm moving right on. So hit stop if you still need to write. I probably won't give you enough time to write everything down unless you're speedy. I like to start with a joke sometimes. This is more of a riddle than a joke. So here we go. The joke at the beginning, or riddle, is this. How do you make 7 even? How do you make 7 even? The answer? Get rid of the S. Got it? If you get rid of the S, it becomes just even. Haha. Okay, that's the riddle joke for the day. Some of them might be funnier than others. Here we go. First word. So the first word is conjecture. Conjecture. The definition is an unproven statement that is thought to be true. And in parentheses down here, I put educated guess. Educated guess you might know from like, a hypothesis in science. So a conjecture in math is very much like a hypothesis in science. It's something, whoops, that you think is probably true, but you haven't proved it yet. So an example over here is this statement. I believe that if you add two even numbers, then the answer will always be even. So if I take 6 plus 8, that answer is 14. It's even. So will that always happen? A conjecture might be that this always happens. If you add two even numbers together, then the answer is always even. We haven't proved it yet. If we proved it, then it wouldn't be a conjecture anymore. But while it's just our thinking that it's true, it's our educated guess that we're pretty sure it's true, it's called a conjecture. So you'll be asked to make conjectures this year. Okay, next word. Here we go. Theorem. So theorem is usually a word we use more in geometry, but we're using theorem in the algebra book this year also. So the word theorem is a statement that can be proven. So a nice short word for that is it's a rule. It can be proven, everybody knows it's true, so everybody uses it. And we don't have to prove it before we use it. We just know it's true. The example you've probably heard about in 8th grade, you should have learned about the Pythagorean theorem. The Pythagorean theorem says the sum of the squares of the legs on a right triangle will equal the square of the hypotenuse. That's been proven. We can draw a picture, we can do some math, we can show that this always, always, always works. So because of that, it used to be a conjecture. Somebody guessed that it was probably true. Then once they prove that it's always true, it becomes a theorem. So that is what a theorem is. I'll be using that word too. Okay, hit pause if you need to. I'm on to the next word. So next word is equation. This is one you should be familiar with. Equation is a statement that two expressions are true. If I've got an equation, okay, so I made a little change on the screen. It should look different now. Equation is a statement that two expressions are equal. I had a wrong word there, I had true. So a statement that two expressions are equal. So an example of an equation is 3 equals 3, because this side of the equation and this side of the equation are the exact same thing. That's an equation. This could be an equation, x plus 1 equals 4. That means 4 and this side have to be the same thing. That means whatever I put in for x here, plus 1 has to be the same thing as 4. So equations are saying that whatever on the left side and whatever on the right side are the same thing. They're equal to each other. Okay, hit pause if you need to. Going on. Solution. Solution is a value that makes an equation true. So the solution for x plus 1 equals 4 is 3. This is the solution. The 3 is the solution. So 3 right here is solution. All right, because if I take that 3 and I put it in here for x, 3 plus 1, I would get 4. Okay, hit pause if you need to. I told you this goes quick. Inverse operation. Inverse operations are two operations that undo each other. Examples over here, adding and subtracting, are inverse operations. Inverse means upside down, means the opposite, okay? Multiplying and dividing are inverse operations. These are important to know when you're solving equations because you have to know what the original operation is, and then to solve it, you do the inverse operation. Okay, next word, equivalent equation. So equivalent equations are equations with the same solution. This should probably have an S on it. Equivalent equations, because if they're equivalent, you have to have more than one. They're equations with the same solution. So 2x equals 5 and 4x equals 10 are equivalent equations because both of these have the same answer. All that happened to get from, and this is important with what we're going to be doing when we're solving equations, to get from 2x to 4x, we're multiplying by 2. To get from 5 to 10, we're multiplying by 2. So as long as we do the same thing on both sides of the equation, we make an equation that's the same equation. It just looks different. But the value of x here, that'll give me 5, the value of x here that will give me 10 are the same numbers. Okay? This whole equation just all got multiplied by 2, both sides, and we made what we call an equivalent equation. This is important as you're solving equations. Okay, hit pause if you need to. 2 more. Identity. An identity is an equation that's true for all values. It has infinite solutions. So there's a couple of things going on here. When you're solving equations, sometimes you'll get what's called an identity. And when you get this as an answer, you can write down one of two things. You can write down identity, or you can write infinite solutions. I'm okay with either. I'm assuming the other algebra teachers are too. If not, they'll tell you, okay? But an equation that's true for all values of the variable. So for example, this x equals x, this top one. If I put any letter in or number in for x, let me let x equal 0. Well, if I put 0 in here and I put 0 in here, 0 equals 0. It's true. Let me let x equal 1034. Well, 1034 equals 1034. They're the same thing. This would also be an identity because if I take any value of x and I add 5 to it on both sides, it's still going to be the same thing. 0 plus 5, 0 plus 5, both of those are equal to each other. And I could put anything x for x here and x here. If I add 5 to both sides, it's still going to be equal to each other. So what we say a lot of times is infinitely many solutions, or you can just say infinite solutions for an answer for this. Okay, last word. Hit pause if you need to. Last word is formula. Formula is an equation that shows how one variable is related to one or more variables. Formulas usually have lots of variables in them. They can also have numbers. My two examples over here have just variables. So this formula right here is the formula for rate or for speed. You probably learned that last year. Rate equals distance divided by time. So this is a formula. What it has is a lot of variables. So we can put in a lot of different numbers for distance, a lot of different numbers for time, a lot of different numbers for rates. And as we change 2 of these, we can always find out the third. This one you might have done too. It's Newton's second law, force equals mass times acceleration. And so in formulas, the variables usually stand for something real life. And you have more than one variable. If you have more than one variable, you can call it a formula. But usually they have to stand for something. There has to be a purpose behind them, not just random variables. Okay, there's 8 questions or 8 words it looks like on this one. So it should be a pretty straightforward test. If you've listened to this, and if you've written these down, looking them over a little bit, it's multiple choice. You should be able to do really good on this quiz. Okay? Let me know if you have any questions. Bye.